Hello and welcome to Sip and Sync with Azure. Today we're going to talk about day in the life of an AI engineer. Now, this has been a pretty hot topic. What does an AI engineer do? Is it different from software engineering? In my mind, it is pretty much software engineering, but you are calling APIs and productionizing applications that are non-deterministic in nature. Now, that entails a lot of different things in the process, and so we are going to demystify all of that today. For that, I have invited a special guest from my team, Anthony Sofio. I'm going to give him a call, and then we get started. Hey, Anthony, welcome to the show.
Hey, Priyanka, happy to be here.
Awesome. So let's get started with what do you do every day, and then we dive into AI engineering.
Yeah, sounds good. So as you mentioned, I'm one of the members of your team, and I get to do a thing that I really enjoy each and every day here at Microsoft, and that is I help some of the largest companies in the world build solutions with AI. And we work with lots of AI engineers, and so we get to see the ins and outs and help with the ins and outs of what they do every day.
So you're part of the coolest team at Microsoft, right?
I am. Yes, I am.
All right. So AI engineering. Let's talk about, in your mind, I described what AI engineering is in my mind, but I'd love to hear how you're seeing customers describing it, and then let's take an example and go end to end deep into the implementation.
Absolutely. Yeah, so AI engineering really is, as you mentioned, it's just another evolution of software development. And we've been helping software developers kind of get a grasp on what life looks like now that they're infusing AI into so many apps. Really, at the end of the day, a large language model is just an API call away. And in many cases, it can be that simple. But there are other cases where solutions can get a little more creative and interesting. And so we have other tools that come along to help us orchestrate those interactions.
So what are we going to see today in terms of this demo, live in action, day in the life of an AI engineer?
Absolutely. So I wanted to do something that was a little more personal to me. And I recently actually made an app for my kids. If there's anything my kids, as we know about kids, they love to be read a good bedtime story before they go to bed at night. And so I thought, could I use the power of generative AI to do something like make a complete children's story with not just text, but also artwork and maybe a few other bonus features in there as well. And I have something that could kind of illustrate the overview of what we're going to look at if you'd like to see that first.
Great, let's do that.
All right, here we go. So the first thing we're going to look at here is what my app does. So here's an example of the cover page of one of the stories that my kids and I created together. This is a cute little story about Thomas the turtle and his friend Benny the bunny, and they're going to get into a little bit of trouble. We might see that here in a minute. But what we've done that applies directly to the job of an AI engineer is we're working with lots of context. We're working with a non-deterministic behavior through the form of multiple agents working together. But what we want to do is we want to kind of constrain that behavior a little bit so that we can have multiple agents work together to create something that is honestly pretty cool.
Great. So what are these agents and how do they work together?
Yeah, so let's talk about that for just a minute. Now, the app that I'm going to show you, it's sizable. There's some code there, and a lot of it we could go through, but what I'd like to do is zero in on the heart of the thing that runs the orchestration. So what I've chosen to do is create what we call a workflow in Microsoft Agent Framework. And what Agent Framework allows us to do is to essentially form a graph of sorts of how agents would interact together. Now, if you follow just kind of my voice from top to bottom here, I can tell you what each of these agents do and how it is they interact. So what you see kind of at the top there with 4 agents in a row is when our user submits a request for a story, one of my kids maybe, they're creating a new story, that request is initially going to go to a story orchestrator. Now, this orchestrator is going to take those details and it's going to form an outline. And it's going to fill in some of the gaps maybe in the outline to make a more robust story. After we have that outline complete, that agent's going to hand off to a story architect, and it's actually going to form that outline into multiple pages. It'll reason about how long the story should be, what the story arc should be, and what the characters should do. After that, the story architect will actually hand off to the art director, and the art director will actually receive image prompts of various sorts, one per page in the story, and it'll go off and create some artwork. And after all that is done, we'll use an LLM as a judge to then grade the story, so to speak, and see if it's coherent and fluent and if it just in general makes sense. Now, once all of that completes and the story is approved, then we get to do a few more fun things. In orchestration terms, what we're going to do is, since we have a complete body of work now in a story, we can take that and we can then fan it out to multiple agents. So we're going to hand that story to a look and find activity page agent. And we're also going to take that story and give it to a character glossary agent. Just a few more bonus pages for my kids to look at and maybe other kids as well. And after all that orchestration and workflow runs, the final story will be delivered back to the user. And then we can look at it. All right, so here it is. So this is the main landing page of the app that I've built. Now, what I'm going to do first is pretty simple. It's just a typical form that you would find on a web app. You can see things here like characters that you can input, and we could put a lot of things in here. They don't necessarily have to be animals, but this is one about a turtle, an owl, and a bunny. And other details here that we're going to send in as prompt context, things like a setting, moral of the story, maybe the central challenge in the story. We also have additional details we could feed here. One of the things I wanted to focus on here, though, are these conditional checkboxes down at the bottom for the activity pages and the story reviewer as well. Now, these may seem like simple checkboxes, but when I show you the code-based workflow in just a minute, you'll very quickly see that checking these or unchecking them actually alters the entire workflow that gets built and run. Now, there is one other little thing that I've put in this app, and I said, could we make this a little more educational for my kids? And I've decided to put in play a technique that we see AI engineers using today just as much as they were 5 years ago when LLMs became all the rage. And that is retrieval augmented generation, or RAG as we call it. Now, I've kept this simple in this case in that Wikipedia is my data source, and I could do something like this and say Artemis 2. And what this will do is an agent will actually go reach out to Wikipedia, go grab some context, and I could choose to have this story I've defined below influenced by this content from Wikipedia, or I could even just make a full story based on that content.
That's amazing. You can bring in extra context from different places and or even like latest news beyond Wikipedia and make it even more educational. This is awesome.
Yep. So why don't we just go ahead and create this story? Now, what you'll see here is a UI that will take us through the workflow. I'm not going to make you sit here and watch all of this. This actually takes a few minutes, especially if the reviewer says, hey, there's things that need to change. But what I can show you is a few pre-saved stories that I have. So Artemis 2 is big in the news lately. I made a story here that's all based on Artemis 2, and it's created directly from that content. We've got a story here about Lily and Ben. This one's actually influenced by the events of the fall of the Berlin Wall. And this one down here is one that I think this was the first one I made for my kids about a turtle and a bunny. And if we click into this and we kind of view it, over on the left-hand side here, you can actually see the full output of the orchestration that ran. You can see it, the whole prompt that was sent off to the agents. And you can even see things like the story architect breaking this down into individual pages of context. There's even the art director down here creating art. Now, if we go look at the story over here, of course, we could page through this story and view all of the images.
What model are you using for art? It's beautiful.
Yes, so this is one of the newer image models from the GPT family. This is GPT-1.5. So it's pretty good at taking prompts and making something compelling. Now, one of the things I wanted to focus on in this implementation was the idea of a thing that AI engineers typically get into. A lot of AI engineers start with text, but undoubtedly they'll eventually move into image generation, even videos, or if we click this little button.
Soon the friends played beside a ring of glowing mushrooms.
They'll also get into some text to speech as well.
Yeah.
This is the app and what it's all about.
Great. So let's see how it's made so that we can actually dive into the details of the behind the scenes as an AI engineer.
Absolutely. So as you would expect in a typical web app, when we hit that create story button, we eventually land at the result of an API call that is made to a backend API. And what I'd like to focus on is this portion of the functionality that actually builds the Microsoft Agent Framework workflow. Now, I hope you'll be surprised that there's only about 50 lines of code here, as I mentioned. And so there's a lot that happens here, but there's not a whole lot of code that we have to write. The first thing that we do here in the workflow is we go instantiate all of the agents that are going to participate in the workflow. Now, your eyes may be catching something that a lot of these are called executors. So let's talk about that for just a minute. When we build a workflow, we're essentially building a graph. We have something that is composed of edges that connect agents together and nodes, or as Agent Framework calls them, executors. And so edges will connect the executors together. Now we can see in the workflow, our story orchestrator is going to be the one that kicks off this whole orchestration. It's going to form that real robust outline for us. And then you can really just very easily follow these edges one to the next, that the orchestrator is going to hand off to the story architect. And the story architect, when it completes, is going to send some prompts to the art director. Now, things do get a little bit more complex as we move through the workflow. As I mentioned, there was that checkbox down at the bottom on if we wanted to have a reviewer actually review the story. And this is where that comes into the workflow. So here we have actually conditional edges that simply say, if this should review method returns true, well, then this edge here on line 105 will be satisfied and execute. So the art director will forward to a story reviewer. But the next line here on 106 is actually just the inverse. If that review button isn't checked, then we're just going to forward this directly on to a final decision and we'll bypass the reviewer altogether. And this line here on 107 is actually a continuation of the story reviewer. If that node happens to be hit, then we will then go from the story reviewer onto the final decision.
So your workflow.py file is basically defining all of the different agents that need to be hit at a specific time, depending on where the flow is.
That's exactly right. Yep. And I have conditional edges. I have even things like this, where I mentioned with the activity pages, where we can completely alter the graph, skip portions of it or include it, or in the case of lines 131 and 132 down here, we can actually do things in parallel, like build those activity pages and then complete the whole story.
Great. How do you do the security stuff that you were talking about and checking those boxes?
Oh, yeah. So this is simply just data that gets sent to the backend. Those are all formed into pydantic models that hold all of the data. You can kind of see one of them here. This request that comes in is actually a story request type. And so we don't do a thing that unfortunately sometimes happen in Python where you don't have well-formed types. But the nice thing about Agent Framework is all of these agents communicate with well-defined, well-formed types. So you don't kind of like make a mess here.
Let's pause because we glossed over the Agent Framework. Microsoft Agent Framework just went GA. It has been around for some time. It's an evolution of semantic kernel and a combination of AutoGen and semantic kernel. Let's talk a little bit about what does Microsoft Agent Framework let you do and how does it make your life easier as you're building multi-agent scenarios?
Yeah, so it makes life easier, I'd say, in multiple ways. One is it gives you lots of out-of-the-box primitives to do things like create agents, and an agent just being something that has a prompt and some context, maybe optionally some tools. And so you get out-of-the-box objects that you can create those locally, you can create those in Microsoft Foundry, and then you can execute them in similar ways. So it does that for you, but then it also does this. It also gives you the powerful thing that is workflows, where you can take those agents and then orchestrate them together. You can replay certain functionality. You can checkpoint in those. And it's incredibly, incredibly powerful to do.
So as a next step then, how do I connect this to, let's say I'm building these agents in Microsoft Foundry. How do I connect them together to let's say, this file that we're talking about, which is sort of the orchestrator.
Yeah, absolutely. Yeah, so you could take this whole app here and deploy it to your compute of choice in Azure. And we have a few options on how we would want to use Microsoft Foundry. So in this case, in this app I've done here, I've kept it honestly pretty simple. My agents live here locally in the implementation, and my models, I have deployed capacity in Microsoft Foundry. Now, I don't have to do that. I could actually go and define agents in Microsoft Foundry and have them live there and run there, and I could just simply call out to them and do it that way as well.
Okay, so here we're dealing with a toy app sort of situation, but in a real world scenario, you would want to make sure that you are evaluating the app. You're also making sure the orchestration's happening well, the troubleshooting aspects as well, monitoring. How do you do all of that?
That is an excellent question, and undoubtedly it is one that every AI engineer will face, is how do I trace and observe my app? And then also, we can talk about in a second, how do I even evaluate agents or prompts as they're running? Why don't we start with the tracing and observability aspect first?
Yep.
So one of the things that an AI engineer has right at their fingertips here in VS Code is an extension called the AI Toolkit. So let me bring that up for just a minute. You can see here in the left-hand tree view, AI Toolkit has a lot that you can do in it. But one of the things I want to focus on relates directly to your question about observability and tracing. Now, I didn't tell you this when we started. Hopefully it's not too much of a secret, but I did have tracing turned on in the form of an open telemetry collector that is actually collecting telemetry from the app as we're running it. If I pull up this view, I can actually show you some of the telemetry logs that we have captured. So if I scroll through here and what we've been doing, I can come down to one of the logs that is a result of us actually generating a full story. And it is the one here that hits my API/generate story endpoint. Now, if we navigate into this, we will see here on the left-hand side a full tree view of all of the nodes of the workflow that we just executed. So here's the orchestrator agent. Here's all the generate story SSE events that go back to the client. Here's our story architect agent. And if we look through some of this, you'll actually see things like the full system prompt that gets sent. You'll see the user input and the details that we provided that actually form the entire story. Now, we can also see things that even a little bit more granular in the metadata here, where you'll see things like the token counts from some of the agents. This was 1,800 tokens input, and we had probably about 5,000 tokens that were output as a result of us creating this story. So if something should happen to go wrong, I can come right here and look through every little bit of everything that the workflow did.
Yeah, this is very powerful. And for an enterprise use case, this is extremely important to know exactly where things went wrong. Also, just as simple things like token counts, right? Because you want to be efficient with your token usage.
Absolutely. Absolutely. And with that, undoubtedly, one other thing that always comes up in AI engineering, along with tracing and observability, is, well, how do I even grade what the prompts are doing? Are they behaving well? Are they not behaving well? Have my agents done something I don't expect? And AI Toolkit also provides some functionality to help you do that in the form of this evaluation view. Now, this is something that you could do directly in Microsoft Foundry. This is also something that you can do right here and get started with here in AI Toolkit. I've been running a few evaluations, and I'll just pull one up now. Just to make a quick comment here about the data set. This is just a simple JSON-L file that has some of the actual prompts from a story generation that I ran earlier today. Now, if I pull this up, in here, you'll actually see some of the user queries and system prompts. Here's some of the ground truth, or really the thing that I would expect the agent to respond with. And here's the actual response that we received from an agent. And if I scroll to the right here, you can see that in this case, we used an LLM as a judge. I used GPT 5.4 for this, and it's doing things like scoring my prompts that came from my actual agent on the terms of task adherence. How well did it do what I told it to do? Or relevancy? How well did it stick to the context? Things like that.
So one of the other questions that comes up is, especially in this type of use case, right? It's children's storybook. You want to make sure that the model doesn't just blurt out some foul language, stuff like that, right?
Sure.
How do you control for that in here?
That's a good question. So the primary way that I've controlled for that in here, again, this is a demo app, so
Yeah.
I've only done so
How,
much,
how
but
would
in
you do
here,
it in general, right?
yeah,
It doesn't have to be here.
absolutely. Yeah. So at least in here, I would say you really attack that from two different angles at the very least. The first one is you have to have good system prompts that can guide the agents. If we were to take time to look at the system prompts in this app, there's actually quite a bit there. Just to your comment, there are specific things in there that say, don't make the story too frightening. Don't make it too suspenseful. That would scare a kid. Make it age appropriate for ages 5 through 8. And there's lots of little details like that. That, though, combined with things like that we have in Microsoft Azure or Microsoft Foundry, you can also set up content guardrails to actually full stop eliminate the ability to have things like harmful language or just crass content that may show up in prompts. So I would say you can do that right in prompts. You can also do it at a platform level. And it's kind of one of the great things that you get from something like Microsoft Foundry.
Awesome. All right. Well, this was amazing. Thank you for walking us through a very personal project, which is also super fun. I'm so glad to even try this myself because I love the artwork that you have in there, and I also love that how simple it is. Right? It's a few lines of code and it's easy to understand. So I'd love for you to share where people can get access to this and where can they get started.
Absolutely. Yeah. So if anyone would like to look at this, it's an open source repo. I would be flattered if you took it and extended it and did whatever you want with it. But you can find it in our Azure samples repo out on GitHub in the AI engineer persona repository. And we can include a link for that as well. And yeah, please do go check it out and let me know if you have any questions about it.
Awesome. Well, thank you, Anthony, and thank you all for watching the show. And I hope this was helpful and also a little bit of fun. And if you would like to give all of these repos a try, they are in the link in the description below. And we will look forward to seeing you next time. Thank you.